not every day, Audrey, when we're talking to folks at Ansys. Ansys is one of these companies we get really excited about.
I know, because they're not only a hidden jewel.
Yeah.
But, I travel around the world and they have a flag everywhere.
They do. It's 100% true. I don't think the sun ever quite sets on Ansys. They're literally a global company. And if you've never actually heard of Ansys, I mean, you've probably seen a rocket launch. You've probably flown in an airplane. You've probably eaten some potato chips. And all of these have been simulated with Ansys software. It's as simple as that, and everything in between. It always blows my mind that Ansys, I think, touches pretty much every product in our lives. And it's
Does it?
Yeah, I think so. And we're going to find out more.
Yeah, we're going to have to find out more.
Absolutely, because we have a guest hanging out with us today that he's going to give us the inside of what's happening with Ansys. And really just, I think anyone listening to this, their mind's just going to be blown with the technology they have, the problems they solve, and the growth track that they're on as well, too.
And, the origins of Ansys.
Yeah.
In terms of how they started. Do you know, are we going to be able to talk about that
Yeah,
at all?
we'll talk a little bit about
we're
kind of
going
how we got
deep
here
then.
and where we're
Excellent.
going.
Yeah. So we're hanging out with Anthony Matarazzo, who's the regional sales director at Ansys. So Anthony, thanks for hanging out with us today. We're just so excited to have you here and talking some shop about what's going on, because it's always one of my favorite companies. We've done a lot of projects with Ansys over the years at the Tech Council, where I've driven a Chevy Volt out there as part of my 2.0 electric tour, where we're taking a car out that was basically engineered by Ansys and had all these different Pittsburgh engineering and products and materials inside of it. And Ansys was our first stop, because it's kind of cool to show off that kind of stuff.
Awesome.
So, and we haven't caught up with you guys in forever. So thanks for hanging out with us. Before we jump into it, your background really in what you do at Ansys.
Yeah, no, I appreciate you guys letting me on here. Super exciting time at Ansys. And there's a lot we want to talk about, especially how we got here and where we're going. But yeah, Anthony Matarazzo, been with the company going over 8 years, right? So I've kind of grown up and seen this incremental change. And I like to consider myself a digital threadist of the Rust Belt, right? Really,
threadist?
What is that? Yeah, I
like that word. I'm stealing it.
But you see a lot of these innovation influencers, right? But do they really know what's going on? And really, are they at the heart of accelerating new technologies from the ground up? So there's no other place better than the Rust Belt to kind of talk about how we're seeing this change, right? Whether it's a company making steel, or a consumer good company making diapers and soaps, to a company putting spaceships on the moon, right? So just really exciting time, and looking forward to kind of walking through some of the cool things here.
Well, how about just set the table? There's a little bit of history to Ansys. Do you know it?
Yeah, so we're going back 50 plus years.
Is it
right?
that long?
Yeah, it's that long. So, how we really started here is a fascinating story. So you have all these companies, right? Like the Rockefellers and the Westinghouses of the world. And our code actually originated from there. So a guy named John Swanson, he was in there and he was an engineer. Engineers are problem solvers, right? So they're trying to figure out, is there a better way that I can fix this issue or improve that process? And, the code, which is a finite element analysis, which is kind of physics-based mathematics, he came up with that, and ultimately 50 years later, here we are as a behemoth in this simulation space. So a lot has happened throughout that timeline, and has been really, I would say, impactful to the world we live in today, right? Anything from, autonomous technology to electrification to looking at digital twins and, next generation space travel and healthcare, about where we're going.
And potato chips.
And potato chips.
My favorite.
So
it's true. You guys have simulated potato chips that don't crush.
So it's interesting when you bring up digital twins, because that's what I would always think of as Ansys.
Yeah,
if that was my elevator pitch.
Yeah, ultimately, when you think of our competition, has been status quo. It's been testing and physical prototyping to look at anything from, the RF performance of a cell phone to the crash of a vehicle, right? To looking at a potato chip, making sure that when you package it, it's not going to break. Or how do you optimize the packaging, right? So we live in a world where things need to be tested and validated and optimized, and it just takes so long to do that. And it's so expensive, and, the workforce isn't there. So think of Ansys as a digital engineering sandbox, right? That's the best way to think about it, where people can go and tweak iterations of what something could look like and how it could perform, and it's all done virtually.
Even before it's built.
Before it's built.
That's what amazes me. It's not even built. You put the specs in, and it knows how it's going to react to wind. Correct. Or a load of some kind, and you can literally, before you build it, build it.
And it's across any physics domain, right? So we're not just looking at 50 years ago in the structural mechanics world. So if something was, bending or twisting or force or impact, we're looking at electronics, right? So how does a printed circuit board heat up? What is the performance of an antenna? What about a motor, right? How do we optimize a motor that has multi-physics or multiple physics, right? Where you have stress and you have windings and you have electromagnetic performances. These are complex technologies that without any simulation technology, I don't know if it would be around today. And if it would be, it'd be like Stone Age.
Exactly.
It would be. Do we credit Ansys for everything? I used to joke with the previous CEO, and he would say, there isn't a company on the NASDAQ or on the S&P that we're, and this was years ago.
Yeah.
And I would say, so you credit Ansys to everything in terms of proliferation of innovation. You go,
I walk through my life day to day, and since I started working there 8 years ago, you never really understand what you take granted for of how is a product made.
Right.
When I was younger, I loved just understanding how it's made, the show, right? Like general curiosity. And when you look at how does that vacuum work? Is there a computational fluid dynamics, understanding the force of that vacuum? What about the electronics? What if that thing drops off the truck? How is the durability or the reliability of that product going to withstand the harshest environment? So anything. A cell phone's a great example, right? It is, I would say, arguably like an Einstein in our pocket. But when you look at the technology components inside of a cell phone and all the things that could go wrong, you're just amazed, right? And that's where this concept of simulation and modeling has just taken off, right? We have made the investments to where our clients have needed us to make them beyond, structural mechanics, fluid dynamics, electronics.
I feel like you've become like the fifth Beatle of many of these companies. They're making the products, but they don't happen without your software being run in order to properly test them and prove them and everything like that.
Yeah. It's when you see what has happened, and maybe I'll go through, post-COVID, when engineers were forced to not be in a lab, right? They were forced to have to adopt simulation and modeling to continue the pace of the innovation.
Oh, that's interesting. I didn't even think about that. Yeah.
That's where we saw a major spike in the adoption of our technology, right? As a software company, we care a lot about our clients. And I always say we get paid off of our clients' success. And the measure that I always use is product vitality. We look at a company and we see the next 5 years of where their sales are going to be. And we focus on what is driving that from an innovation score. So that way we tie ourselves to technology and what's going to make them successful and how they're going to achieve their, technology milestones and their corporate goals. You look at something like sustainability, which I find is fascinating too, is you see these ESG and sustainability development goals, but when you peel back the onion, because I've done it with some Pittsburgh-based companies, with those in the central U.S., you see that how are they actually changing or impacting their goals, right? So everyone talks about emissions, right? So carbon footprint.
Right. How do they measure that?
How are they measuring it? So at Ansys, what we're able to do is help companies accelerate the discovery of alternate materials, replace plastic with paper, maybe use a different alchemite as a metal type, right? So these are tangible changes that will impact the world, right? And impact their actual
Ansys
goals.
inside?
Yeah.
So instead of Intel, it's Ansys inside.
That's what we're going.
So your hypothesis is that no one can exist today if they produce something without using Ansys.
Ansys are equivalent, right? So we're not the only game.
There is no equivalent. I'm sure you have your competitors, but
yeah, there is an equivalent. There are actually two, right? So our biggest competitors in this space would likely be Dassault Systems and Siemens.
Never heard of them.
Not in the Pittsburgh area, but they're largely known for PLM,
Absolutely. Okay,
right? Product lifecycle management, and CAD, right? Computer aided design, and they do really well.
Surely.
But what we've done, what makes us unique and differentiating, is our DNA since 50 years ago has been in physics-based simulation and modeling. So we pride ourselves on the breadth of our technology and the depth, right? There's no other company in the world that can go from multi-scale to multi-domain modeling, right? So that's looking at a chip, okay? So at a semiconductor integrated circuit chip to understand like the electrostatic discharge, the reliability of that chip before it goes into a tape out, which is tens, maybe hundreds of millions of dollars. How does that chip make its way into a system? Could be a circuit board, which makes its way into an electric motor, right? And then that electric motor making its way into a vehicle, whether it's in a locomotive or it's in some sort of car or even electric aircraft, right? There are multi-scale, multi-domain engineering problems that our competition, they don't like to play nice.
They
right?
can't go from level to level to level the way you're going. Like
and
you said,
we're
starting at the chip, and
correct.
as that chip goes into bigger and bigger products, you can continue to simulate based on
For
that.
sure. And the future of that is going to be take consumer goods, right? They look at next generation technology and they need industrial electronics, right, to be able to integrate that. And the key part of that is going to be semiconductors. I mean, look what Intel is standing up in Columbus. So I feel like that vision is coming to light, and we want to play nice, right? So simulation doesn't exist in a vacuum either, right? So we have to work with the CAD companies, the PLM companies, the ERP companies, like SAP, good example, right? We want engineers to not only be able to design for performance, but why not design for cost? Why not be able to leverage your supply chain where you're getting your raw materials? Because another thing coming out is PFAS, forever chemicals. I ask this question to every Pittsburgh-based company. What is your strategy whenever that time comes, like the EU has, where you have to be able to accelerate a different material? You can't use cobalt in a battery. And they all say, well, we're going to get to it when we get to it. And it's never a problem until it's a problem. So at Ansys, again, that's a parameter. It's a trade-off, just like weight, durability, risk. I mean, these are trade-offs that simulation is used, really is a superpower to make those decisions.
So with your software, then they could substitute that with a different material and then run the test to see how it performs. And then they can find the best substitute for that material and do it without having to actually build the product for real. That's just game changing.
It's interesting that it's so predictive as well. So
predictive outcomes, right? That's what there are some Pittsburgh companies that they're looking for. Right, and engineers solve problems. Ansys has software that solves problems, and then we go into the AI era, which is all about computational models and solving problems.
Well, let's go there because
what has changed?
Yeah,
AI has been around for 4 decades, so it's not like it's an overnight.
What's changed is the earliest releases of AI. Everyone's seen ChatGPT, what it's done. Right, it's made someone like me a genius, I would say.
You weren't a genius before?
No, I wasn't.
I noticed he was pretty smart, Audrey. I was like, look at this guy. Yeah. And it's ChatGPT all the time.
It is ChatGPT. So now I'm powered by ChatGPT. But when you look at it, it's really cool, right? Because our customers, our clients are sitting on 50 years of simulation and modeling data. What are they doing with it? It's collecting dust on a server.
Interesting. So, there's all that data there from what they've done. So you can start mining that and using it.
So there's a lot, and I don't want to get too deep here, but there's things like physics-informed neural networks where we're actually able to go in and first thing we do.
Wait, you said physics-informed neural networks. That sounds cool. I'm sorry. Just saying that, I'm like, let's talk more about that.
Okay, keep going.
Yeah, so the team at Carnegie Mellon, like those guys know it best, right? So there is a reason why Microsoft, Google, Amazon, NVIDIA, like they haven't tapped into simulation data, right? They're going after everything except simulation data. It's because the mathematics behind the models, right? Ansys, again, let's go back to it's in our DNA. We know the code. We know how, fluid dynamics or electromagnetic properties, how they are influential to each other, right? That is not super trivial, right? So what we're able to do is we're able to capture those models, train those models based on influential parameters of a design, which is like engineering talk of, hey, I have this model. These are the 5 things that if I tweak will affect the other's performance. So we take those models, we train them, and then we're actually incorporating an aspect of Gen AI where based on a customer's requirements. So if I work at another company using Ansys and I want to deal with an automotive OEM, you give me the requirements of this is the shape, this is the function, this is the material, this is the look and feel. We have these simulations built on the back end where they're actually running tens of thousands of scenarios and iterations. And then our AI will actually be able to go and find the optimal design. So we're searching and finding the optimal design. And if they don't find it, we released a new technology, SimAI, earlier this year that we will actually generate a new topology based off of, could be test data. I mean, now we're getting outside of just simulation data. We're augmenting and we're kind of taking this hybrid analytics approach where we're taking test data, taking simulation data, and we're starting to fuse and generate design. So when I say it's next level, we're
what are you
peaking.
going to do to all the designers?
So we're going to augment them, right? We're going to take designers and traditional simulation analysts, and we want to make them practitioners, right? So the key here is to leverage the best and the brightest engineers at our clients and repurpose them to focus on complex new innovation. A lot of the time when we go and talk to these companies, they have their subject matter experts working on the day-to-day modeling, the carryover designs, the repetitive designs, the things that are computationally extensive or expensive, right? I mean, these models, like when I started in 2015, it could take a couple hours to prep a model, maybe hours or days to solve the model. And then you got to make an iteration, and the hardware at the point in time was all on premise. There was no big cloud offering. Right. We fast forward. Now we have this AI that's able to automate and drive some of these models' designs. We have the cloud, right? Thanks to companies like Amazon and Microsoft and Google. And now you have NVIDIA and these companies that are pumping in GPUs and CUDA GPUs.
They got the chips that can make it happen, right?
Is just,
yeah. Mm-hmm. So it's kind of like all these things are kind of creating this they're coming together, I guess, at this point to make all this happen with the hardware, with NVIDIA, you have cloud and all these things that you didn't have in 2015. And it's like this next generation that's just ready to take off on now.
And what's the next generation of skills? What are you seeing in that?
Yeah, I think that's a great issue that everybody's having now is the people that built this country, they've been baby boomers, right? They are working hard and they've earned every job that they've ever gotten and they've proved themselves. Now I'm a millennial. We have millennials, we have Gen Z. They want answers quick, right? So they're not as loyal, and I hate to say that, but our old customer base, super loyal to Ansys, especially in this area. We have this user conference, and it's kind of like died off, and it's turned more into a technology conference. But what I think it's going to take is people that have a passion for pushing the limits, right? Challenging the status quo. I think you have to have that characteristic. You have to be curious, right? I think there has to be an element of wanting to do more with less, right? Everybody talks about it. That's kind of the foundation of AI. They want to win more programs in less time. They want to design more with less resources. So these people are kind of working smarter, not harder, which I think that's kind of the path forward anyways.
Mm-hmm. And what about the fact, what I love is I remember it was a few years ago when you made your big presence at Carnegie Mellon, obviously with Ansys and the software is available for the students to use, which I love. I mean, the idea that some of these students can tap into the world's most powerful design software. I'm like, oh my goodness, that's got to be just blowing some minds and just setting that next generation of designers and scientists that are going to be using your technology because they had it from day one.
Yeah, what we're doing is ultimately we have an academia partnerships team that is really focused on driving this innovation and unlocking our technology at all major universities. I think it was Cornell. They had this massive online course, right, where thousands of students were participating in it to help self-educate, teach, and learn, what is the latest in simulation modeling? Where will it take you? And what is the impact it will have on your career as well as the industry, right? So we have a big investment into that space, and we're going to continue doing that.
You've done that for a while.
Long time.
Yeah, we've done that for a while. I mean, your presence is not just in Pittsburgh and Carnegie Mellon and the University of Pitt. It's almost everywhere you land, which is really just a brilliant branding strategy over time. So can we so this language, I'm going to get back to digital twins. So this language of digital twins, we're not hearing that conversation.
Yeah, so digital twin has been I would say a buzzword for quite some time, right? And everybody has been trying to figure out, how do I unlock a digital twin? I'd argue that the hardware wasn't there a couple years ago, and the expertise of modeling wasn't there. So we're working with a few companies in the space of like making materials, whether it's materials like an adhesive or materials that is like construction equipment, right? Think of it that way. And some of these companies have had digital twin strategies for years, but what has been the hurdle is the amount of data that they have to gather to make that twin accurate, reliable, and then where does that information live? So our software has totally been capable to doing that, right? We have this method called a reduced order model. So as you run a simulation, we could take it and save it into a lightweight version of that. So we mirror what the simulation is seeing versus what the asset's actually generating. We synthesize that data. Now, again, we need a partner. We need a partner that is like an IoT backbone. That's not us, but we need something to connect that twin, because right now we can build it as like an offline twin, whether it's anything in the manufacturing world. damping, sticking, machining, tuning, twisting, all of those processes, right? There's simulation for product design, and there's simulation for kind of manufacturing and development processes. So I do see that in the coming years as a big opportunity, especially as all these companies want to, increase operational performance, right? Look at downstream effects of, hey, I have a pump in the field. Before that pump fails, can it read me back? I need to tweak this valve and figure that out. Or maybe I'm a consumer goods company and I want to figure out, how do I make more diapers faster?
Right.
If those things are shooting down a conveyor belt line at 150 miles an hour, we need air or wind that's going to hold them down. And then, by the way, we want to make sure the oven doesn't break, right? Because that might be the influential part to that process. So,
Absolutely.
Yeah, I definitely think you will see more of the digital twins come to life as I feel AI is kind of catching up to it. And again, like our digital twin technology is going to be augmented by AI, right? So we're going to take test, simulation, smash it together.
And so do you work with companies that are like in life sciences at all?
Yeah, so we are agriculture, one of them. The other area would be like kind of in the healthcare med device space. Is that where you're leaning towards?
Yeah, I'm just curious in terms of where your sectors are.
Yeah, so we operate in pretty much every segment, every industry. So aerospace and defense, automotive has been huge for us in the last couple of years. Consumer goods, high tech. I actually think the two areas of next generation growth are going to be in space, right? Like Westinghouse is a great example. So we just had a press release with them where ultimately they are putting these small nuclear reactors, sending them to space so we can explore kind of what's out there, right? They're going to power space. You see it with the James Webb telescope. I think this is it's one of the best stories. And there's a Netflix documentary, not on Ansys, but on the James Webb, where there were, I forget how many failure modes, right? Those are things that can go wrong in space. Number one, you can't physically test space. Number two, space is so complex. And number three, a million things can go wrong and one thing can go right. So that is the perfect example of simulation running tens of millions of scenarios, situations where effectively it goes perfect, right?
Yeah. Wow. That's kind of mind numbing.
There's really another, I want to share this with you because I'm clearly passionate about this.
Yeah,
so the Artemis mission's coming up, right? And we work a lot with different companies that are supporting that mission. And one of the key things to getting on the moon is having connectivity. So 5G, 6G communications up there. Now, there's no other company in the world that could actually simulate the performance of a mission. Now, we're talking mission simulation where,
the whole mission.
The whole mission.
Whoa. Okay.
So you got a rocket.
Yeah.
Tens of thousands of components on that rocket. Each of them are influential to that mission's, operation, if you will.
Just getting off the ground, right? Yeah.
And in order for that rocket to get to space, and let's think about next generation space travel, the moon is going to be a landing zone. Okay, so VTOL, you're going to go up, you're going to dock on the moon. To get to the moon, imagine going to New York City without a traffic system. What would happen? Chaos. So we go there. We're going to help these companies build out 5G infrastructure to have a base station, astronauts, vehicles, and understanding the connectivity between all these systems. And without having, going back to it, the chip, the package, the system, the environment. We're even modeling the lunar surface. We're taking dust and looking at what happens when the dust gets inside the rover.
Right.
Does it screw up the frequency? It's really...
Oh, my goodness. And then on top of that is that all this is happening in a vacuum in the depths of space, which is you can't really...
Correct.
Wow. Oh, my gosh. That's so amazing.
So Ansys has presence everywhere. How many countries? Every country?
I would say a lot. Yeah, I don't even have the exact number, but
a lot. I like that.
We just stood up the site
Many.
with Carnegie Mellon in Africa. So I know that was a big one for us because you're looking at next generation talent. And I think that is a huge opportunity for us.
Definitely. Wow.
Right.
So obviously, you have so much fun doing what you do.
Love it.
Ansys, I think you might have the Ansys tattoo somewhere.
I always say I say I'm a lifer. Right? I kind of fell into this role, but it's not even a job for me.
I fell into the role?
Yeah. Somebody contacted me as a recruiter, and at that time, you couldn't get hired. This is 9 years ago. You couldn't get hired unless you were a PhD or you had enterprise software background or you knew physics, and I have none of that.
No physics.
I'm a marketing guy at heart. So I went there and I was just like, this is the coolest place I've ever seen. And, when you go to the office and you see Red Bull Racing and how we're helping them like win these races, and you look at F1 and any company, I could sit here for days and talk about the companies that actually leverage our technology. And it's just,
and the ones you can't even tell us about.
Yeah, no, there's something we
It's
can't.
like,
We can't tell
You'd
them.
have to kill them.
I know.
I wouldn't walk out of this room or
No, we wouldn't walk out of the room. Other
And
way
so
around.
there was an acquisition, right?
there was.
But Ansys is still going to be called Ansys. Right?
We're still going to maintain the
autonomy.
the Ansys brand and the technology. And, the further we get to this acquisition, if you will, the more excited that our company gets, because it is a testament to where the world is going, right? Where we see
it shows the direction where everything's heading, and you guys are well on that route. Yeah.
I mean, if you guys had a chance, I'm not sure. We had our simulation world. We brought it back this year, and NVIDIA's CEO was actually our keynote speaker.
Oh, nice.
And how this isn't, it's an awesome example of, I call it circularity, right? The companies like the NVIDIAs of the world and those that are developing semiconductors, they use Ansys to design the chips to help make the GPUs. Those companies then make the GPUs that go into these cloud infrastructures, this hardware that is required for Ansys to run our technology. And
Right.
I love
then everybody
the
else
circular.
benefits.
Exactly.
Every industry, everywhere.
Very
So it's like good
interesting.
vibes. It's good vibes all across.
It's good vibes all the way around.
So what do you do for fun?
So I'm actually going to have my fourth kid. So
We said
fun
we
is
said fun.
4 under 5 all girls. So let me
Oh
tell
my
you,
goodness.
I tell Ansys all the time, I'm the biggest women in technology supporter.
100%.
So I spend my time raising children, and I like to do fun things and go hang out with my friends. But I can't even talk to them sometimes, because when people talk about what do you do for work, and I'm like, honestly, I'm helping put a 5G communication system on the moon.
Exactly.
Or I'm meeting with a company that's heavy industrial manufacturing, and we're going to flip what they're doing from internal combustion to electric drive to hydrogen. And that's going to power the world, right? It's not even, we're not even on the same frequency, but I love them.
So
And
it's hard to have friends, huh?
it might be. I mean, that's why I have all these kids, right? So we just,
Well, I loved about the fact you have these 4 daughters is the fact that, man, you can be an awesome role model to show them how awesome technology is.
STEM.
And
Also,
get them
awesome
engaged with it.
to let them know that his life and work bleeds together.
sure.
Yes, very much so.
And
Absolutely.
it sounds like it's not that you don't differentiate, but you're saying, they talk about people having passion, right? But it's also what you're good at.
Sure.
So I like to say, yeah, passion's great, but what are you good at? So it sounds like you're really good at taking complex information
That's it.
and then synthesizing that and articulating it in a way that is digestible.
I would actually say that's what I
say
to
spot
people.
on.
When people say it, if I were to give that example, it's exactly what I say. That's why I've been able to build these relationships with executives, because
Right.
all they want is, how are you going to impact my profitability? Right? Top line, how are we going to make more money? Bottom line, how are we going to save more money? So if you can tie together how simulation is helping them achieve their goals financially, this is where partnerships are
But
made.
you also have another dimension that's important, and that is the priorities of the world
Sure.
and the constituency of people who work for companies, what
Yeah.
matters to them.
Yeah.
So you've also got to address that. And it sounds like, from just listening to you, that that's also on your plate
For
as
sure.
well. So what does it mean to be sustainable? What does it mean to have, a closed loop economy? What does it mean to, for reuse? So I can imagine people want to reuse materials,
100%.
right? That there's eradicate waste. Make sure that they're using the best materials, given, what we know about different materials now.
We did a study, this is a couple of years ago, and we found that a company's number one cost to their overall profitability is materials. So when you ask that question is, are you designing with optimal material in mind? A lot of the time, because it goes back to these companies can't afford to wait and see, right? They have a finite amount of resources to be able to design these products or these systems or these processes. So they're really not optimizing to their fullest, right? And that's where you augment that with AI and you allow them or you enable them to do that. We're going to see dramatic change in the coming years with looking at sustainability.
You know what? I think the other exciting thing from listening to you and the work that Jonathan and I do is that you don't necessarily have to have a PhD in organic chemistry.
No.
It's great that we have people that take that path, and we need them. But the critical thinking and the flexibility and the adaptation paired with a basic knowledge of tech, I think is what we really need. So it'll be so interesting 10 years from now to see who needs to get a college degree, where they get, what are the stackable skill sets? How does a guy like this in marketing?
Well, it's got universities, I think, freaked out already if you think about how they're justifying what they do now and how it's going to have to change to be part of this, for sure.
Here's a guy trained in marketing, right?
Exactly.
And he's like, no, I sort of can go deep and I can go wide.
Yeah.
And I know how to figure out a way to sell it.
It's interesting you say that, Audrey, because when I was talking with Anthony on the phone before this, we're just kind of get to know each other and talk about what we would talk about. And I was really excited to have him stop by because like I said, no disrespect to engineers. I love engineers, but engineers can be tough because they're engineers. They're looking at the pluses, the minuses, the ones, the zeros and stuff. I was like, he knows what the engineers know, but can bring it down to terms so the rest of us can understand. Yeah, exactly. And also his passion for this is just through the roof, which
why?
Really cool.
You have little kids and you ask them something and they say, why? Why can't I have candy? Well, because it's not good for you. Why? You keep asking those questions and you get to the
5 whys.
Keep peeling that onion back.
Japanese practitioners.
Yes.
Yeah.
So I try to apply that, and you got to understand what matters most to who you're talking to. So an engineer, what do they care about? Feature, function, get me the right answer, plus or minus 1 degree.
Exactly.
Their manager, you know what they care about? I need 10 of those engineers to be as productive as possible so we're not late. That director cares about the overall program or the design and making sure that they're going to meet those timelines, actually exceed them. And by the way, they have to deal with some geopolitical issue. And then you go up, and you eventually make to a shareholder where they're like, if we don't enter this new market and we don't achieve this product vitality score of X%, we're out. So when I say companies can't afford to wait and see, they almost can't.
They can't, especially in this day and age. And that's where it becomes like Ansys is, your technology is just going to be so core to any business that wants to be competitive in this day and age. It's like if you're not using it, you're losing it, man. Simple as that. So,
I call it executive FOMO.
Yeah.
We try to play that.
I like it.
What are you doing to stay ahead? How are you going to be on top?
Well, it's hard. You got to have people around you who have a lot of inquiry and they know how to solve problems. So to me, I think the next 10 years in terms of what people focus on in terms of their academic preparedness is going to be telling.
Yeah, and you had a question or a comment, and it made me think. Simulation has so much intelligence behind the scene, and where we've been stuck for 50 years is it's been stuck with an engineer to make those engineering decisions. Now what we're doing is through the help of like AI and automation and building out these solutions, we're putting simulation in the data that it's generating in the hands of salespeople
and business people.
And business
people, yeah.
So they can use it to say, okay, I'm going to go generate that quote for you, that RFP or that RFQ, because on the back end, I have these automated simulation workflows that are going to give me the design, the performance, the cost, potentially the timelines. So now we've cut, development cycles. Automotive used to be 50 months. Then they cut down through just leveraging simulation in half, and now we're getting quicker and quicker.
You keep drawing that closer and closer, right?
The supply chains going to have a difficult time catching up. That's the next.
Well, that would be the next holdup, I would have to assume, is that they literally can't get the product there fast enough because you have something that can be built, but you're like, I still need that product to get here.
Well, and also when you start questioning the supply chain.
Yeah.
Because it used to be this product, and now you've done simulation and saying it's not that material.
What about replacing I always say this, replacing a weld with a rivet? Companies that are, heavily manufacturing industrial equipment, they're welding. Welders are, number one, they're a dying breed, or maybe they're up and coming again, but they're expensive. It's time consuming. A rivet, quick, bolt on, snap fit, whatever.
Or that special glue they use in cars.
Or special glue, right? So those decisions most companies haven't had the luxury to be able to optimize their products performance.
They keep going the old way because they don't have the time in order to even test that out.
So one of the things, I know I'm talking a lot here, is
no, we like you talking a lot.
When I explain simulation to somebody, it's been a superpower for engineers, for organizations to kind of look into the future, right? To predict the performance of this change to a design. Thanks to AI and where we're going, we're now able to latch onto the past and leverage the past to inform the future. So really, it's like simulation across time, which is like mind-blowing. It's like next level. I don't even know where this goes.
Because you're harnessing existing data that you had, and you've never been able to plow into it.
Yeah, you've never been able to use it for anything, but now like, it can be harnessed, and it can inform how you build something, and that might be on the moon.
Sure.
And that's what has my mind blown is like, oh my gosh, like Ansys is working on stuff for communication.
It's hard for me to walk around and just look at things, and I see commercials, and I hear my dad or my mom talk about a car. And I spent 4 years in Detroit working with the automotive suppliers that were feeding the electric motors and the power electronics and the inverters for all the cars you see today. Like at Ansys, we get a snapshot into the future before it happens. Like I was seeing this technology get developed, radars, lidars, cameras, sensors, all this technology around autonomous, right? We're working with those suppliers, right? We're behind the scenes working on real-time radar. What is that? It's if I drive a car underneath the tunnel in Pittsburgh where you have all these challenging scenarios, how is that radar going to pick up a guardrail with a specific material going under a tunnel? I'd argue, guess what you need? You need multi-scale modeling of the antenna to make sure the paint that's on the emblem of the car is like corresponding appropriately. And then you're blocking it. So now we need the scenario. We need to map in with 3D physics, like the entire mission. So everything to me is like mission critical systems of systems simulation, right? That's where we're going.
Okay, that's too cool.
I don't know whether to pity his 4 girls.
I know.
Or it should be
exactly.
Wow.
I think I'm wild.
Right?
I'm going to say wild, but I know where you're coming from.
I'm trying to make them future ready. I guess
they're going to be
say.
more than
No
future
one's ever
ready.
future.
No way.
Love
But
it.
when it comes to, we had the take your kid to work day at Ansys, and it was great because it happened to be the same day as our board week. So I take my 2 older girls in there, and our whole senior team's there. And, my 2 girls are super excited. They talk about Ansys all the time because I talk about it. And one of them said, do you know what your daddy does? And they said, yeah, he works for Ansys, and they build cars. And my other one said, well, they build airplanes. And honestly, like the answer's right? Like we don't build them, but we sure as hell like help make them, help develop them.
We can talk about airplanes offline.
Yeah.
Yeah, there's probably a whole conversation right there. I have a simulation if you take some bolts out of a door, what happens, but yeah, we'll figure that one out later. Anyhow. Oh my goodness. I tell you what, I just love being able to hang out with somebody that's having this much fun doing what you're doing for a company that's literally transforming whole industries and really how just the world's going to get business done.
Yeah, I mean, your energy is contagious.
Yeah,
no, thank you.
We love it, man. It's a good thing.
Well, I wanted to get on here just because I'm a Pittsburgh native, and I went my whole life two things. When I got to college, one, I never ate an avocado. Okay, that's just a fun fact. I feel like people don't know.
I was in my 40s before I was like avocados, gross. Then it was like, whoa, these are a thing.
Now I eat them every day. So
yeah, exactly.
Didn't know about an avocado.
Okay.
And then the second is I didn't know about Ansys, and that really bugs me now. Is I went that far in my life, and the people around me really never knew what we do and the impact we have. So like I've made it a personal mission to join the company and tell the story. Because there's 50 years of just massive success and innovation
stories,
that's come out of here.
With that,
that's great.
And much to be proud of, I would say, because it's these things like you said, people take for granted when their computer turns on and when things work. It's like, no, it's because it's been simulated very well.
There's some engineer to thank.
There's some engineer to thank around that. Oh my goodness. What an amazing story all the way around. Like this is one of the things where we want to stay updated because we know, obviously as things keep changing, we want to be up to date as to what happened. So we're officially handing you the TechVibe open door policy.
Love it.
Where you're allowed to come in whenever you want to dork out with us and talk about some of the latest things that you guys are up to, because Audrey and I have been huge cheerleaders of Ansys forever and forever. And it's been too long since you had a conversation like this, because we're of the same mindset that we're like, man, this is one of these companies where, yeah, people need to know about it.
Well, what I say is every meeting I go into, I say, okay, who knows Ansys? Everybody raise their hand. When's the last time Ansys was here? 2 years ago? Okay, we're going to reintroduce Ansys, right? Because ultimately, we are evolving just as fast as technology is evolving. And I'd argue that it's outpacing humanity. So we have to continue to educate. And look, I think at Ansys, we're just getting started, right? We have a lot of really cool things to come to market, and I'll be back for sure.
That's why you got the open door policy, because you could just see all the cool stuff first, man. Simple as that. So let us know how they're working on the LiDAR and those power inverters.
You got it. You'll see it driving around, or look up in the sky, or go home and you'll see.
You're the best. Thanks for hanging out with us on TechVibe.
You guys got it. Yeah, anytime.